also today it's more of like familiarization with the tool itself, but we are going to do that with a project here. Yeah, so the idea is to design a power supply. Say we are getting 12V input from a battery, and we are supposed to design a product that should give us an output voltage of 5V and 3.3 volts at 1 ampere. That's the current. Also, we are told to use some LED feedbacks. We do some protection of the input and the output, also include a switch, and make the design as small as possible. So once you have such a problem, well, it's up to you now to start identifying all the components that we need to use. And you realize that I want to capture everything that we've gone through so far. Like when I say we need to use some feedbacks, and we're using some LEDs there. For us to get the 5V output, it means that we need now to use voltage regulators there. We have mentioned this when we were dealing with ICs, and it's pretty much easy to identify these ICs. Just like I was saying, it's a matter of us going to the vendors themselves, searching for like an IC that can give us 5V and maybe 3.3V. We can use 2 or 1, it depends. So I think we can begin this. So those guys that will join us later, they will catch up with us. Because also, again, as usual, we want to keep the session very short, yet very productive. So I'll fire up my KiCad. Yeah, and I'll open the project that we created last time. That was our first KiCad project. Still here. And you just go to the first KiCad project. So I'll remove what we did last time. Don't need this. Just highlight and just left click and say delete block. Okay, so yeah, fantastic, because it's very easy to create a new project in KiCad. Just go to file and say new and project, just give it the name, and once you save it in your directory, it will just appear here. So what you should just do is click on the schematic here, and it should open that window here. So if you're on Windows or Linux, it will open this in another window. For this case, I'm on a Mac, so it gives me a tab. It's just the same thing. You can have it like also popping it out, but just prefer it this way so that it's easy to navigate through the tabs here. So the next thing we should have on our design here, let me just keep them very close here. So we should be having our supplier open, and this is ideally, and why I'm doing this is because this ideally the entire process of design. So we need like power supplies, so we can call them LDOs. They're called LDOs. I've mentioned this. They are called power management ICs. So these are our power management ICs. So we will search for what we are looking for in regards to these requirements. Let's say, make sure we are good. Yeah, I think that's okay. So these are our requirements. So we can see the maximum voltage input from the battery will be 12, and we need an output of 5V and 3V3. So let's see from our vendor here if we can get this. So we just go to the output voltage here. So maybe one thing that's we should first of all set this. Let's set the output current to 1 ampere, because that's what we need as the output. Yeah. Then also let us check in stock. We are lucky. We can have one that has 2 output channels or 1 output channel. So it's up to us to select whichever. So I can take like for to two channel. And this is something very interesting here that I'm doing as an example, because I know most of us are not used to like designing with ICs that got like two outputs. And let's see if we can get the two outputs that we need. That's from the voltage here. Well, I think we are not lucky, because what we have here is 1.8 and 3v3, but we need 5v and 3v3. I don't know if we have such a combination here. So let us just reset once more here at the current. So you can always play with these things here until you get the best that you needed here. Let's see the voltage. We needed the voltage output here. Let's see if we have 5 here. Let's say we have 3v3 and 1.2, 3v3, 1.5. Well, in that case, it means we are going to design, like for each case, we will design 1, 1. So what we do, let's just select one output channel, or just leave it. Then we can select here at 1 amp. And just apply the filters. You can put it to be a fixed output so that we don't have to search a lot again. Then you can just look at this, and whichever makes us happy, we just select it here. Yeah, I think I like this. This one's from ST. You just click this. So I want just to take you through this simple process here of just selecting components so that we can start with the design. Don't want just to jump into KiCad and stuff and start doing, well, even though that these particular lessons, the first ones, are mostly oriented in terms of how to use KiCad, in terms of tools, not essentially how to design. But I'll just keep on touching to that because it's basically relevant. So like I told you, once you see the datasheet, there is nothing more you're going to do. You just go to the schematic application. I've just clicked on schematic, and what's here, we just copy this. It's very simple. So what we are going to do, we're going to KiCad now. Remember, so I'll keep on. So if you can be making some notes in terms of hotkeys and stuff, well, we can have our co-host also making some notes for our members here on the chat, because if they don't, so that they can remember the keys that I'm going to be using. We said to place a component, we can use this symbol here. I can click on this and just come and click here. But again, I can just hit A on my keyboard. So to placing components, I can just hit A and it will fire up this window. So we can have Stephen, make sure you are giving us the hotkeys there that I'll be using through the lecture. So we can do LM. We are searching for, we had this here. We are searching for LD117. This one here. Let's see if KiCad has that. This here, LD117. Yeah, luckily this regulator is there. We have LD117/6SS3. We need this, and we need for 5V. I think we wanted 5 volts. So we can select this. You just move it and place it to where we want. And I see we also have one for 3v3. So just hit A here. I'll hit A for shortcut. That's the hotkey. Then I'll search again LD117/1117 then for 3v3, because we'll be needing the two of these, because we need one for 3v3 output and one for 5v. Yeah, I remember our requirements here, the output itself. And again, you can see the datasheet output here in terms of voltage and current here. So most important on the datasheet, where to check, you can see they give us here the output. They say it's 1 ampere. But again, you can also check this at electrical characteristics. This is something that you will be wanting to look so much here. So once you come here, you will get all the parameters that you need. And of course, it continues with all these. And the output current should also be here within this. For instance, I can see it here. We see output current here. We have minimum is 1 ampere, and typically we can have even 1.2 amps. So it's the unit here is milliamps, but of course we can convert that to 1.2 amps. So when you are reading the data sheets, most importantly, we'll be checking, and I'll continue explaining more on this. This is just a highlight. Don't mind too much about this for now. So we'll be looking at electrical characteristics so that we can cap our limits. So again, remember, we are copying the typical application. You need not to know how it's connected, because the data sheets will give us. They are telling us that we include a 100 nanofarad cap at the input and 10 microfarad caps at the output. But we're going to do it slightly different. We're going to add more, and I'll tell you why, because we've learned about caps and we said that more the caps is important. So I'm going to hit A to fire the components. Then I'll search C. I'll say C, and again, in KiCad, say you want like small components, I can say C underscore, then I just do small, so that I can get the smaller one. So I'm easily getting the smaller package here. So get C. So for you to change this value so that we can have the value of this, I'll hit V. So I'll just hover and hit V on my keyboard. That's the value. And then I can write here, like they are telling us to use 100 nanofarads. I just say 100 N for nanofarads. Then I can just place it where I want. So if I want to put another capacitor here, just instead of just me repeating the whole process of hitting component A and stuff, I can just hover on this and hit C to copy. Just hover and do C. I copy that and bring it on this other end. Then I'll hit V to change the value to 10 microfarads. So 10 U for microfarads. Then what you can do now, you can do a combination of this and another cap. Like I can copy this and add another one like 0.1 microfarads. Again, I can also do the same here. And again, at the input here now, we can use a polarized cap rather than now having just ceramic capacitors. And polarized caps in KiCad are written, they are given as CP. If you type CP in KiCad, you will get now polarized. You see they will be having like positive and negative, and I want to go with the US symbol here. It's called CP1. Also, I want to go with small, so I'll do that. So I'll pick this and I'll place it here, positive to go to positive, negative to negative. So I'll change the value also. I'll hit V for value. So, and this one should give us the exact value. So we can use 10 microfarad at the input also. So let's say you copied this and you placed it here and you want to change the value also and maybe other properties. You can also hit E for edit and it will fire up this, and we can change it here as well. So you can also use E for edit. So if you want to delete, just use this tool and delete. So what we are going to do now, let's make a connection here. So we can use now, well, also we can press ground for this. So we can hit A again. Then we type ground here. Remember, we said we can just search it from here as well. So what I'll do, I can just place one ground here for now. So to connect the wires, remember the hotkey is W, or you can just use this one here, wire. You can just hit W here and then you just move this. So I'll just do this, left click, left click, left click, left click, move this and left click there, you left click, move your mouse, left click, move this, left click, then left click again, I left click and that, left click and left click. And this end is done here. So this particular side of the circuit. So if you want to move this, you can just left click anywhere, somewhere far, and then just drag your mouse and then you can move this to wherever you want. So we also need some inputs where the battery connections or terminals will be. So what we do, you just hit A, we search connectors, you can just say con, it will give us all the connectors that are available here. And we want one with, say, with one column and 2 rows. So I can just type this, or you can just type, if you just type connector here, connector, it will give us all the connectors. Connector is W1, connector. If you search connector, it will give us all the connectors that are available here. So you can just scroll and you will have all of them here. And so you can select, like for this case, maybe I want 1 times 2. And also, like I was saying, you can just get it quickly by saying just con underscore 01, you multiply that 02 and you just grab that. Just it selects this, just hit OK, move this. So let's say you want to rotate this so that it can face on this other direction. What you do, and you want it to stay the way it is, you can use Y for mirror, because we want to mirror along the Y axis. Hit Y on your keyboard and we have it change that way. So we can have Y to mirror on the Y axis. So if I do Y, you see how what's happening. If I do X, it just changes now along the X axis. So we just leave it at that point. So and then I'll do some connections here. This way we'll be connecting our battery. So we do left click and left click, left click, left click, because this is at the input now. Okay, so we can also do the same for this other one. This is the 3v3 regulator here. So what we'll do here, we can just copy this. We'll treat it the same way. This a way that you can do it. Now, me copying these symbols makes it very fast. But again, what you can also do is, we can ignore this. We can just keep this one here. Then let's delete block, right click and delete block. So what we can do, we can copy everything here. We say like copy block here. And then I can do Command V or Control V in PC. So Command V or Control V. So there, and then I can just paste this. Then because this is not the one that we need, we just take delete this, and we move this one here. To move this one, I just hover here and hit M. Hit M on your keyboard to move this and just place it here. So we have these two connected here. So something else that we wanted to add here, this is 5V. We can add a power flag here. So we just hit A and say plus 5V. Say OK, place it here, do a connection, 5V. This one is plus 3V3. So we do this, power V, 3V3. So we can grab that and put it here. So place. So the next thing that we wanted to do is to add LED feedbacks. So what you just do, hit A on the keyboard, just search L, say LED. We can do also LED small. So just hit OK. We want to rotate this, use R to rotate. I think we should have that shortcut as well. R, you can do this to rotate. So I want to rotate it this way. So remember, we need a current limiting resistor so that this LED does not glow too much, and probably so that it may not blow up. Just hit A on your keyboard and search resistor. So I said like you can use R, just do R, and this is the resistor here. If you want the other symbol, you can do R underscore US. For this case, let us just go with R. To change the value, again, remember value is V. Hit V on your keyboard and we can go with something like 1K. So we need to connect this and connect it to ground as well. So we can copy ground here. So just hover, hit C on your keyboard, move. If you want to move this and align it, hit M on your keyboard and hover it here. So left click, I just hit W on my keyboard for wire, just left click. So if you want to do a wire and just want to terminate it somewhere, just double click and then you can move your cursor. So if you just single click, it just creates an anchor point. You don't need an anchor point for now. You just want it to like terminate the wire there. So double click, then copy this, just hover, hit C and then move it there. So we need this, same for this. So what we do, just highlight this, say left click, no, you right click here after you hover, then say copy block, then Command V or Control V on your keyboard to paste here. We want it to be for, this should be 5V now, but we want it for 3V3. So hover here, hit C to copy and paste it here. So Once we are done with that, let's see what else we need. We need to protect the input and the output. So we use fuses. So, and that's something probably we should have done earlier, but it's also good because I'm going to introduce some other tools here that you should use. Probably you may not have used them before, like